Hello, this is Harni. Welcome back to our YouTube channel Code with Harni. Today we are going to solve LeetCode 2028 challenge. Count number of maximum bitwise or subsets. So, before solving this question, I will highly recommend you guys to solve the subsets questions, so we'll know how we will be generating the subsets basically. So, a subset is nothing but a subsequence. So, if you just take a look at this example, they have given the nums 1, 2, 3. What are the possible subsets that we'll be getting as 1, 2, 1, 2, 1, 3, 2, 3, 1, 2, 3. So, it's like combinations of all the possible nums. So that is the subset. To generate the subset, you can use recursive way or memorization. Basically how a subset will be formed. So this is our nums, right? So initially, when you are passing this, okay, as an array, we will be uh, considered to whether you are taking that element or not. So initially our result will have empty subset. Now you will be traversing through this array. Okay. Now our first recursive function will be like, okay, I'm going to take my 1. Okay. And second will be, I won't, will be traversing through the loop. Okay, I won't take 1, and whatever this 2 3 left, okay, you can take. So this is how the recursive loop: pick, don't pick. So this for the second loop it will go 2 3. There again it will come, okay, I'll be picking 2, I won't pick 2. So again you will be passing this 3 alone. Then there, pick 3 or don't pick. So like this we will be keep on traversing. Okay, again when 1 comes here, this recursive loop, again I'll be like, okay, I'll pick 2, I won't pick 2. Okay, so then it will go to this index here, then it will be like, okay, I won't pick 2, then what will be straight away still passing 1. So when here comes, okay, I'll pick 1 2 3, and if I don't pick, what it will my recursive tree. So then it will go to the next loop, but still there is no if you don't pick 3, there is no more further traversal exists, right? So from here it will return. Okay, if you don't pick, there is no more. Hey, we have reached the end of the index. So this will not have any further recursive tree. So now if you just take a look at this, okay, if you don't pick 2, what it will be our case? We can pick 1 3. Next, if you don't pick 3, okay, it was the end of the loop. Okay, the same way here, if 2 goes, here I picked 2. If I don't pick 2, what will be if I pick 2 and my next was 3? If I don't pick 3, okay, that is the end of the loop. So this also will return. So yeah, now if you see, we have generated by pick, don't pick, we have generated all the subsets, right? So yeah, like this we'll be generating all the subsets through recursion. So if you don't pick the recursion, there is another way called bit manipulation, where if you just take a look at this example 2, which is length of 3. So generally 2 to the power of n subsets we will be generating. 1 2 3 4 5 6 7 8. So 2 to the power of n subset you will be getting generally. So 2 to the power of 3 is 8. Got it? So now if you see, for how about we set our mask as 2 to the power of, if it is 8 4 2 1, in this case to set 3-bit set. So this is nothing but 2 to the power of n minus 1. This is our mask. Okay, 7. I have set, my length is 3, I am going to set the 3 bits, so I'll get the mask as a 7 by setting this. Okay, until mask will be keep on having the mask. Okay, while mask. So now you initially you will have the I as n minus 1, which is 3. So n is nothing but length of the nums. And now I'm just telling how we are going to generate a subset. Okay, so now if you are give I equal n equals to 3, 3 minus 1 you will be giving 2. So now what we will be doing, now at this point we'll keep on traversing through the each nums where this particular bit is set. Okay, that you will be taken that particular. Okay, now here 3 3, so now 3, this bit also set, this bit also set, this bit also set, so which means I'll be appending that to my result. Got it? So while now I'll be having the copy mask equals to mask whatever it is. Okay, and my resultant subset is equals to empty. Now while basically what it does is, so if you see with for this bit we need 0 1 1 1, for this bit we need 0 0 1 1. Okay, 0 0 1 1 1 3 means 0 1 0 1, 2 3 means 0 1 1 0, 3 means uh, 0 1 0 0. So 2 means 0 0 1 0, 1 means 0 0 0 1. So if you know mask or till 7 our mask will be the same, right? 0 0 0 0 0 1 0 0 1 0 1 0 0 0 0 1 0 0 1 1. So by traversing through the mask of 7, okay, and whatever the bit is set to 1, and if this bit is set, first bit is set, I'll be appending that now. So like that we'll be doing copy and 1 comes. Okay, we'll be appending that corresponding nums of I. So initially my bit will be 7. So if I do and of nums of I copy and 1 is 1. Let's assume our bit is 7 0 triple 1. Okay, now whatever you are appending I will be for I equals to 2, you will be appending 3. I equals to 1, you'll be appending bit is set to 2, I'll be appending 1. I equals to 1, I'll be appending 1. Like this you will be appending in answer. Okay, then you will be keep on subtracting I minus or equals to 1, and our copy will shift the 1. So initially my 1 here, then I'm setting my bit here so that to get that particular bit what is set or not. So once you are done with this, you'll be keep on moving the bit towards right. Okay, first to get whether the particular bit is set. Okay, now 7 got traversed. Now we have to go to 6. So basically we'll have 7 subsets. 7, now my mask will be 6, so minus or equals to 1 by this. Initially when my mask is 7, I'll be appending 1 2 3. When my mask is 6, 1 0 1, which means 1 2 3. What will be my resultant array? 1 3. When my mask is 5, those are 8 4 2 1. 6 means 1 2, 5 means 1 3, then 4 comes 1 0 0. Now I'll be appending only 1. When 3 mask comes, we'll be appending 1 1 0, which means 2 3. Okay, now 2 comes 1 0 0 0, which is 2 alone. When 1 comes, which is this, that is nothing but 3. Okay, now if you see you have all the subsets, right, by setting the bit and our mask is nothing but 2 to the power of n minus 1, which is the length of the nums. So this number of subset you can form. So by this you can avoid recursive stack space. So this is nothing but to generate how much this loop will go. So 2 to the power of n and number of bits, which is nothing but to the max it will go 3, length of the bit, so which is nothing but n. Yeah, so this is our time complexity to generate the subset. I hope now you guys would have understood how the subset, these are the subsets. So now this is how the subsets generation work. Now our question is number of maximum bitwise OR subsets. So which just states like we have to generate maximum possible bitwise OR of a subset of a nums and return the different non-empty subsets with the maximum bitwise OR. We have to, so here if you see for this 3 1 we have different subsets 3 and 3 1. Those are the maximum R that is giving. So the count of those subset is 2. So here nums 2 2 2. So all non-empty subsets of 2 2 2 have a bitwise R. So yeah, everything 2 will give you 2. 2 will, so to the max we have maximum of 7 subsets, right? For n equals to 3 will be having a maximum of 7 subsets, so that's what we are returning. So for the nums 3 to 1 4, so these are the 6 subsets that gives us a value of 7. So if you just take a look at all this example, so generally if you are XOR of all the values, all the num in the nums will give us maximum subset, sorry, maximum bitwise R, because if you R is nothing but if the bit is set, another bit is not set, also it will, R bit will be set basically. That's how or bitwise R works. So to the max how many possible nums we have, if you taken everything into account, so it will lead to our maximum or value. So we have to return maximum possible bitwise OR of a subset, right? So yeah, now we'll have a better understanding how we have to generate subset and how this maximum possible subset works. So by just taking the subset bitwise of OR of all the num in the nums, we'll get to know like okay, that is the maximum bitwise R value. So then whatever the other subset that gives us the same bitwise R, that will be taken into the account. Okay, this also contributes to this maximum R. So we know how this maximum R works, and we have to traverse through the each subset to figure it out. Okay, this whether this is equals to the maximum R. Okay, add it to the resultant array. Like this only we'll be going to approach this solution. This is the example that we have taken to for the subset generation, how the subsets work. So now the same, let's take the same example. So 1 2 3, what is the R of 1 2 3? So 0 0 0 1, so this is 2. So now 3, right? So to the max we'll be getting our maximum X or is 3 for this. Okay, so now we have to figure it out, is there any other subsets that contribute to our X or 3? Okay, now if you see for this X, this XOR of 1, this is 2, this is 3. Okay, so one subset we have which is 3, other which is 3 other than 1 2 3, so the count is 2, this is 1, this is 2. So now 1 3 also will contribute. If you see here, this is 1, this is 3. Will it contribute to 3 or not? So generally how the bitwise OR work means, so if you are taking any XOR of anything, what is the maximum, that will be your resultant XOR. So 1 3 obviously will come. So 2 3 if you take also, it will see 2 is nothing but 1 0. So if you take the same 3 will come. Okay, the count will get 1 2 to the max, our XR will be 2. So already we have taken this into a account. So to the max, our resultant maximum XR that we got is 3, and number of subset that contributes to the 3 is another 3 we have. So in total we have 4 as a answer. So now we know how we are generating the subsets, right? So now you just take a look. This is the mask, which is total will have a length of here n equals to 3, right? So we'll be getting totally 7 subsets. So by setting the mask of the each subset, which is what is the value of 7 6 5 4 3 2 1, so by that we'll be able to generate all these subsets. Okay, so that we will be adding it to our result, so we know these are the subsets that will be generating. Okay, now in addition, how will in addition to this, how we will be modifying our subset solution to find out what is the count to get the maximum, to get the subset of, to get the count of the subset of maximum XR. So first we have to, what are the nums we have, we have to taken the bitwise, we have to take the bitwise OR of all this to get the maximums. Okay, exact. So what for that, what we will be doing for num and nums, will be having a max or value or equals to num. So this max or value now will have your maximum R value, and our count will be 1 for the any, for at least one will have the max R, which is the whole length of the array will have the maximum R value. So we'll be taking that as a max R value and we'll be taking one. So whenever we are doing what whenever we are doing we are setting this bit, right? Instead of this, what we will be doing, will be taking our current R. We don't want to store it in our answer. Instead of, we'll have a current or value equals to 0, and instead of appending, what you will do, current or equals to nums of I, because that bit is set, so which means 2 3, so it will come every time, or 1 2, or 1 2 3 something it will come. So now what we'll be doing, now we'll be keep on, instead of adding it to the array, will give us a subset generation. So now we'll be doing XOR of these values in a current R, and instead of adding it to the result, what we have to check, if the current or is equal to max or value, then count plus or equals to 1. Since it has generate from 7, it will also include 1 2 3, so we can just take it as a 0 initially to the count and in return count. So yeah, by this we'll be getting our the same subset generation. Instead of adding the subset to the resultant array, what we will be doing, we'll be keep on XOR of these values, and if that XOR of the value matches like the same, here 3 3 3 comes, right? So the maximum XOR value will be 3, and the same, if the 3 comes, we are incrementing the count. So like that we can increment our count, we can use the same subset generation code to uh, find out the maximum XOR value of any subset. Okay, or maximum XOR value of any array, which subset, sorry, what is that? So by using the same code of subset generation, we can figure out the maximum R value of each subset that contributes to our maximum R value. we can figure out the current R value of each subset that contributes to the maximum R value, and we are adding it to the count only if the current subset R value matches with the maximum R value, because they are asking us to return the maximum R value of the any subset. Okay, so maximum R value, how we'll know? By if you have taken all subarrays into a, sorry, all values of the subarray. If we are taking all the values of an array, that will contribute to the maximum R. Yeah, because as you keep on adding any number to the, as you keep on doing R of maximum number, it will increase our bit, so that will contribute to the maximum value. So that's why we'll do or of all the values in an array to get the maximum R. So whatever the subset that contributes to the maximum R value, that will be taken into account. That is the maximum possible bitwise R of a subset of nums. Okay, so this is the approach one. The time complexity is same, 2 to the power of n, and the space complexity is order of 1. For any array, okay, to the max, we have a max xr value is by doing or of each num, right? So by then we'll know what is our max xr value. Okay, so what we are going to do, okay, what is this xr, for this xr value, what all the subset that contributes to this xr value. So what we will be doing, so to the max, let's take a dp array. Okay, that will have, to the max we can generate 2 to the power of n. So they have told n equals to 16, so we'll take a dp array of 2 to the power of 17. Okay, so initially we'll set initial dp of 0 equals to 1. Now, for each num, whatever we are traversing, we will be counting max xr value, right? This is the TP array that is used to give us the number of subsets. Okay. Now, if you take initially, okay, dp of 0 equals to 1. Now our nums will go in the range 1, 2, 3. So initially our max xr value is 0. So for 1, 0, uh, for 1, max xr is 0. Okay, now I equals to 0. So 0 or 1 will give us 1, right? So for dp of 1 plus or equals to dp of 0 is, okay. So to form one xr value, okay, only what are the possible subsets? So how many possible subsets? Only one we have. Okay, that's it. So now the this loop got terminated, right? Max xr value will get updated to what is our current nums of I. Okay, now max xr value got updated to 1. Now the loop comes here 2. Okay, so now I will start from nums of I equals to 1, will starts in the range from 1. So 1 xr of 2, 3. So for dp of 3, dp of 1, how much, how many subset, whatever dp of 1 will already have the number of subsets that contribute to the dp of 1, right? Now if you are doing xr of 2, what is this current xr value has, with this num, these many subsets can contribute. For this num, these many subsets can contribute to form this xr value. So we are just adding that dp of I to this dp of I xr of num. So which is like for to form one xr value of subset, Okay, we already have 1. So now again for 3 also will be having 1. Okay, with 1 and 3 I can, with 1 and 2 I can form 3, where the which subset already which is contributing to the value 1. So now I will go to 0. Okay, now 0 of 2, which will give us 2, right? 0, okay, 2 also it can form 1. Okay, so to form xi value of 2 we have one subset, to form 3 we have one subset, to form 1 we have one subset. Okay, so this is the xi value. So these are the subset number of subset count that will contribute to this xi value. Okay, now our xi will get updated to nums of it will get updated to 3, and num will go to 3. So max xi value is also 3. So I equals to 3, xor of 3 is nothing but 3. So 3 plus or equals to, so dp of 3 plus or equals to dp of 3. So dp of 3 what? 1. Now again 3 alone can contribute to this xi value or not? Okay, 3 alone can contribute to the xi value. So now we'll be updating, okay, another subset also there too. Yes, so now it will be getting updated to 2. Now I will go to 2. So 2 3 also contributes. So this is 2. Okay, 2 3 also contributes to the xi value 3. So again it will get updated to, as we have seen here, right? So 3 will also contribute. Now 3 alone contributes to the 2. 1 3 we have already figured it out and we have added to the initial count. Okay, now 2 3 also will get added. So dp of 2 3 is 3 plus or equals to dp of 2, which is 1. Okay, so how many subsets that contribute to the xi value of 2, which is 1. Now this is 3. So these if you are doing this xr to 3, you will be just appending the value. Now we are updating that value to 3. Okay, now I equals to 1. Okay, 1 and 3 also contributes to the xi value 3. So dp of 1, which is 4. Now hope xi value is 3 or equals to 3 is 3. Now return dp of max or value. Okay, yeah, that's it. By this we'll know what is how many number of subset that contributes to this particular xi value by just doing this with the current xr. If you are doing the including this num, okay, basically what we are not doing anything. So initially we are taking this and the current xr. Okay, so tell if including 1, how many subsets that contributes to this xr value, to this max r value. So then with including 2, max r value get incremented. So by with including 2, how many subsets are contributing to the max r value? Okay, next after including, now if are including 3, how many subsets that contributing to the max x value? Like that we keep on calculating the subsets that contributing to the r value, and thus r, if you are doing this, basically adding the current num into our count. Yeah, I hope this makes sense. For this time complexities is nothing but the same n cross max r value. To the max will go till uh, to the max will go to the max r value, and the space complexity here is 2 to the power of 70. Yeah, the previous approach doesn't have any space complexity, but it has a time complexity n cross 2 to the power of N, and this has lesser time complexity, but it has space complexity. Yet both has its pros and cons. GitHub link solution in the GitHub link. Please do check it out. If you have any questions or queries, please leave feedback so that I can help. Yeah, if you do like my video, please do like, share, and subscribe. Yep, thanks for watching.